for the presentation on fundamental of software testing. So with this presentation we will try to understand the basic concepts as well as the levels of testing, the approaches and so on. So the agenda is working around with the role of testing, verification and validation, failure, error, fault and defect, that is the terminologies that is being used. What is a test case? What do we mean by an expected outcome, that is test oracle? And what are the issues? And along with the white box and black box testing, we see the research arena for this particular area of software testing. So, the role of testing, the quality assessment for software is divided into two categories. One is static analysis and another one is dynamic analysis. Static analysis examines the code and reasons for all behaviors that might arise during runtime. Now, this is done by code review, inspection, algorithmic analysis. So, you never get a chance to execute and possibly see the outcomes. In case of dynamic analysis, you go for actual program execution to expose possible program failure. So now, behavior, as we all know, is being presented at the exterior and you can reach up to the quality. Now, quality is a kind of an NFR. You are all aware about this, and in case like this, where you abandon the program execution and line up with the program execution, the static and dynamic analysis are complementary in nature. So, there are two terminologies, verification and validation. So, what these two mean? The verification is a process level issue, whereas validation is a product level issue. So therefore, building the product correctly, it is about the process that has been adopted for building the product correctly. And as we all know, that is process is set of activities performed to attain a particular goal or objective. So this process for testing will be following certain steps which are being coming under the software quality assurance. Now validation is the building the correct product. That is, you are talking about the correctness, means it is about the software quality control. That is, whether the product meets its intended use and purpose. Moving next, first we will begin with an error. Error is a state of the system. Error is not a something which can be restricted by value or quantity. It's a state. It can lead to failures. Now an error is a mistake or misconception or misunderstanding on the part of software developers. So there is a knowledge that is existent about the error. The actual cause of an error is not really the mistake, misconception and misunderstanding. What leads to error is the fault. That is the root cause of an error. A fault that has been introduced in the software that may cause the software to behave incorrectly at the exterior, because exterior assessment is also required. So now a fault which has been reported by the customer or client is called as a defect. A fault that has been reflected or communicated by the client side is called as the defect. Now failure is the cumulative kind of an interaction that happens between the errors, and then the required performance is not being met, so if the performance degrades, naturally the product will not be acceptable. A test case, likewise, the test case should do the execution conditions. What are the conditions? So, with this state of database or configuration of hardware device, that is the setting up is required. This setup is called as test bed, on which the program will arrive. It will be supplemented by the test inputs and what are the expected outputs. So, a comparison between the expected outcomes and the actual outcomes is being compared, and if there is a mismatch or if there is a too much kind of an deviation in this, the test case passes but the program fails. Remember that the intention of testing is to reveal the errors, is to reveal the faults, and without going into too much kind of a general cases, the test case should have test bed FASTA. Then the comparison should be done with the test oracle, that is consisting of the expected outcomes. This will be compared. Any kind of an delineation or variance, if it is not been tolerable, then the program is in a failed kind of a mode. But when the program fails, the test case passes. So one has to be very much serious about the pass and fail criteria about the test cases. We know validation is a product related terminology. So it is usually associated with execution based testing, that is exercising the code with test cases. Now, in the present scenario, the code is not directly embedded. You are narrating the scripts based on which the test cases are being executed. So, if let us say you have a program of 100 lines and if it has got certain conditions or predicates, then these conditions should be evaluated. So therefore you can insert the breakpoints or checkpoints, maybe statically after every 10 lines or at the predicates. Okay, what is being getting evaluated, that must be remembered, that will act as the security check of your program. Yeah, and verification is a kind of an static analysis technique, that is to satisfy the condition imposed at the start of the phase. So verification is allied with inspection and reviews of the code. So officially there are code inspectors, code moderators, and the outcome of the discussion should be on revealing the defects in the software and what are the corrective measures that the programming segment or the developer should take. So therefore, there are three things now. The fault localization, that is to isolate the fault, or debugging is the process of locating the fault or defect, repairing the code and retesting the code. Now after retesting the code, the test case should be passed by the program. It means that it should generate the expected outcome as compared with the test oracle for a particular test bed. Now there is variance of test bed. What infrastructure you require, what is the operating system that you are working around, which is the programming language, okay, what is the level of that language, right? So testing an assembly language program is difficult than testing a C program. So as you work around on the levels of abstractions of the code, you will find that the insertion of the checkpoints or the breakpoints would be an effective as well as efficient kind of a process. So moving next is the slide again demonstrating validation and verification. Includes testing infections and then the static analysis. Whereas the actual requirements are being given and validation includes usability testing, user feedback and so on and so on. So when you are working around with NFRs, that is non-functional requirements, then you are doing black box testing. That is testing it for exterior. The examples of black box testing are regression testing, stress testing, or you can say load testing, or scenario based testing, risk based testing. So there are multiple approaches here, but we will not consider all of them. So can you get what you want always? You can't always get what you want. But the appealing thing is that you can't ever get what you want. This is why, because every program has got properties. These are required to be submitted to the decision procedure. That is to pass or to fail. So if program passes, then only it can be acceptable. If it fails, then naturally countermeasures are required to be taken. Now, for simplicity purpose, a student, let us say, replace the program by student. Students have got properties, characteristics, the courses registered. The decision process is being, made complex. So, if the student passes, it means that no defects are been there, no errors are been there with the students, right? I mean, AA grade, AB grade, this is not working around with the donations, right? This is working around with the evaluation schemes and policies. So, test cases, they have the policies, right? Correctness properties are undecidable, and the halting problem is an haunting problem. What I said is that abruptly program stops the execution and it will be resulting into nightmare. That is haunting problem. So the halting problem should not lead to a haunting problem, right? So there could be nightmares, okay? So testing being a very, difficult job, and programmers cannot fool the testers oftenly, either by associating dead code or glue code, just increasing the lines of programming language source code, and so on. So this is the SDLC V model. So here you can find that we begin with requirement specification and reach out to the code. What next then? Next is the terminology of the testing begins. So unit tests are being performed on code. So typically you use the code coverage criteria. You can have the debugging tools, dynamic analysis tools, right? Then you move ahead with the detailed design where integration tests are being taken. They can be taken into the order top down or bottom up. And then you perform system tests and acceptance tests. So the V model for the code you can of course take up before the debugging and dynamic analysis tools. You can take the help of static analysis tools, likewise inspections and reviews before landing into the automated tools which are being called as coverage tools. Then the next study that is about the system test and acceptance test is about the performance of the system. So you can have the comparative analysis, the test cases which are being passed, which are being filled, and then on that you determine the ranking of the programs or the code or the system. So therefore, in simple terms, component under test is been called as cut, class under test is also called as cut, the module under test will be called as MUT, and system under test is called as SUT, SUT. So the activities are there. Likewise, this is again the example of the V cycle. Actual needs and constraints are being submitted, specifications are being reviewed, and then you perform the module tests for units or components. Now about component I have said cut. About unit it will be UUT, right? So subsystem test and integration and delivered package will be all there with the help of verification at the initial level and then achieving it through the complete automation. So now let us go towards the history of testing. Uh, it has begun in which year? Typically it is an unknown area, the debugging oriented period till 1956, demonstration oriented from 57 to 78, 21 years big story, 79 to 82, destruction oriented, 83 to 87, evaluation oriented, and 88 onwards, how to prevent the errors. Okay, so this has been done uh, by two important entities in software testing. One is Gelperin and Hazel. They published the article on the growth of software testing in 1998. So now, in debugging phase, what was there till 1956? Okay, the testing was not differentiated from debugging. Software problems were submerged with the hardware reliability. Nothing much about the uh, debugging was being known. You have written the program, then you have checked it out, it's okay, it's accepted. Yeah. So clear boundaries were not being defined. In the demonstration area, testing was to make sure that software satisfies its requirement. Now just say to it, okay, there is a slight variation here from programming world, you are entering into the world of requirements. Then debugging, the process of making sure that the program does what the coder meant it to do, and then the program solves the problem that it is intended to solve. So picking up the correct problem was a story because the field of software engineering started evolving, okay, from the year 1967 when Walker Royce devised the waterfall model 1. So in the demonstration phase, there was a first formal conference on software testing in 1972, and 73 was the year program test methods was being written by Hazel, and there were efforts in 1975 and 78 about some of them were about the fundamental theorem of software testing, then software testing and test documentation workshops. And you see over there Dr. Barry Boehm, who devised the spiral model, and later it was being incorporated in unified process, who was been commenting about the software quality characteristics. So in the destruction phase, the orientation was testing to detect implementation fault. Observing that testing is a job which lands you in mud. Okay, so testing is the process of executing a program with the intent of finding the errors. So Exhaustive testing, you cannot do all of the test cases, you can't write. So destruction based story, it isn't deserved too much kind of an potential, and then later on it was migrated to evaluation. With the evaluation, the verification and validation and testing methodology was being suggested, incorporated in 1983, suggesting the guidelines for having the correct error-free software. So, first time it was felt that along with the development, you require maintenance of the system also, so as to address the issue of quality. The last era was prevention, testing to prevent faults. So some of the techniques were being fault seeding and then experimenting. So that required experimentation up to certain extent, right? And Hitzel again written one book which was widely accepted, that is the Complete Guide to Software Testing. And you can see STEP, that is Systematic Test and Evaluation Process. Here you can recollect the waterfall model. This is based on waterfall model: analysis, design, implementation, execution, and maintenance. So this is what is the summary. In 1950, it was oriented towards fixing up the bugs, then exhaustive testing, that is test each and everything, but that was not a possibility. Then prove it works. The program has been working. And then prove it doesn't work. That is the destruction era. Then defect prevention and test process. Then from the year 1983 onwards, test automation tools were being there into the scenario. But the advancements were not really effective. And then in 1990, early test designs, advanced test automation, and then internet was being matured enough, and then optimized business scenarios were being there, resulting as an outcome from year 2000 onwards. So there is one more issue that one should address while testing: is correctness, reliability, safety, and robustness. A program is correct if it is consistent with its specification. So no deviations are being allowed. So correct functions for some unit of behavior is indicator of reliability. Safety, preventing the hazard for the software. Robustness, acceptable or degraded behavior under extreme conditions. So these extreme conditions are required to be first specified, and what is the recovery pattern that will be followed, that has to be noticed. So with the help of the diagram we will try to understand this thing. Typically you can remember this as RCRS: reliable and correct, robust and safe. RCRS. Just see to it: reliable but not correct, correct but not safe or robust, safe but not correct, and annoying failures can occur. Robust but not safe, catastrophic failures can occur. So robustness is an essential characteristic, as well as reliability is also important characteristics. Then later on, correctness and safety, they have an intersection zone here right at the center. Okay, this is the Venn diagram. You can understand. See the overlapping sections: RC versus RS, and the relationship between reliability and robustness. So there is something called as fail-safe mode. Fail-safe mode, right? So majority of the terms we have studied. Just this is a repetition of test oracle. This is a document or piece of software, yeah, that suggests something to pass or fail. Test bed is an environment that contains all of the hardware and software that to test the software component. Quality relates to the degree to which the component or system or process meets requirements. So it covers SQA as well as SQC. SQA stands for Software Quality Assurance and SQC is about software quality control. About metrics, I will not speak too much. So these are the testing principles. There are certain 10 principles which have been resulting into the 11th one. Testing should reveal the defects and it should yield in evaluating quality. And the test should not repeatedly identify the same kind of an defect. You have to identify the undetected defects. So a test case must contain expected outcome and the result, that is called as test oracle. Test results should be inspected meticulously. They should be written, okay, the test cases should be developed for both valid and invalid input conditions. And then tests must be repeatable and reusable. So when you are narrating a script, this is the outcome that you may gain. And let us reach out to the 11th point. Testing is not a dirty job, as it was being failed into the era of destruction. Testing is a creative and challenging task. Now, the scenario has to be understood correctly by everybody. I mean, even though you will be narrating the softwares for any kind of a system, your challenge will be how to test it. Whether it is a creative kind of an application or system, that will depend on the way you test it, how much rigorously you test. So it will take up the time, it will take up the cost, and that's why it should be planned and it should be accommodated and integrated into software life cycle. So what a tester needs to know, he should be educated for specification, design documents and development scenarios. A tester needs to reason like a scientist. That's why creativity comes in. Tester needs to have good grasp of problem domain. So just see to it that experiences with the particular problem domain is the need of the hour. Tester needs to create and document the test cases with the test procedures which are being embedded inside the test cases and running the tests. And naturally, newest tool advances as well as cooperation is being sought, okay, from the other developers and clients and users. So strong kind of an communication network or channel has to be formalized enough to do testing. Now, testers are also human beings. They are also having their own mental life, and Boris Bezer, who was author of Software Testing Techniques, still this book is being used in many of the syllabi worldwide. There are the phases. Phase 0, no difference between testing and debugging. Yeah. Phase 1, the purpose of testing is to show that the software works. Next is the software doesn't work. Phase 3, purpose of the testing is not to prove anything but to reduce perceived risk. So, and the last phase, testing is not an act. It is a mental discipline that results in low risk software without much testing effort. So, the fourth phase is very important for all of us. That is, testing is not an act, it's a mental discipline. So therefore, if you are joining the development community, why not testing community, but with a different mind frame? So now, defect life cycle, okay, or the defect, how it is being starting up and closed down. Detect, report, assign, in progress is working around on the defect, fixing the defect, retesting. If it is resolved, then close it. And if reopening is being suggested, then there exists a failed verification. Yeah, if it is not been resolved, uh, naturally you have to open the issue again and address it as a fresh. Now, while assigning also you can reject, saying that it's not an issue, it's not reproducible, and you are not going to fix it. So, which is the dangerous one? That is, you won't fix it, isn't it? While rejecting. This is a denial of work. So, don't touch to the extremities that I won't fix the bug if you join the testing industry. Defects, they are categorized into requirement defects, design defects, coding defects, testing defects, and there is a defect repository, or in short, industry nomenclature says that it is a bug repository. So, requirement and design defects, functional defects, feature defects, feature interaction defects, and interface description defects. So, that's why while setting up the feature set document and the SRS, we have to narrate the correct description, correct characteristics, what is being expected out of the product. And in the design, as it is the next phase, algorithmic and processing defects that are being meant towards the pseudocode, incorrect design of data structures, and lastly, external interfaces are been badly designed. Okay, so descriptions are indicating lacunas. So, typographical defects can be easily controlled, initialization defects can be controlled, data flow can be detected, and now what about code documentation defects? So out of date code documentation affects testing efforts. How come? Apart from stabilizing the syntax errors, you should work around on semantics as well. So just in previous session we listened about the various version control systems, right? RCS to CVS to SVN and to the distributed world. Project was an example. Now, this is about the how testing maturity model can work out. That is level 1 initial, level 2 phase definition, level 3 integration, level 4 management and measurement, and optimization is the highest level. Now, test harness. This is the important term. That is, in order to test the software, especially at unit and integration levels, auxiliary code must be developed. So there must be alternative approaches to achieve the correct specification. So this is called as scaffolding code or overlapping code. If this doesn't work, the next one will work. This is the faith you can have. So, objectives, it does work, it does not work, reduce the risk of failures, reduce the cost of testing. Right. Again to remind you, failures is the cumulative effect of the faults plus errors. So therefore, test case. What is the simplest kind of a form of this? Here written the user stories. So test cases has got the simple pair of input expected outcome. So stateless systems can be tested and state oriented. that are also can be tested. But in case of a stateless system, test cases write up is static. That's why it is simple to test. But the test cases in case of real-time kind of an examples, that is state-oriented, the state is been changing. So therefore the outcome depends on the current state of the system and the current input. Then the situation becomes complicated. So expected outcome, that is called as the test oracle. It is a mechanism that verifies the correctness of program outputs. So uh, here again IUT stands for input under test. Right. IUT stands for input under test, and the complete or exhaustive testing means there are no undisclosed faults at the end of the test phase. So you have to determine now which one are the valid inputs and which one are invalid. So if we can address this issue, probably if the program is handling too many kind of an inputs, then a compartmentalization like this would help us to test the right properties and eliminate the wrong ones, right? So this is how it works. Input domain D has got D1 and D2 domains. You have got the D1 of D to test program P, and it is possible that D1 exercise only part P1 of P. D2 will be of course there for P2. So can we segment the program like this? So therefore you can give selected inputs for program P which is executing under an environment and observe the actual outcome and then assign the test verdict whether the test cases passes or fails. Next is the level of testing, unit testing. Units such as procedures, methods in isolation. In integration testing, modules are assembled together into a larger subsystem. System testing, the subsystems are being integrated, so you target the functionality and load, and the acceptance testing, you work out with the customer's expectation from the system. So therefore, there are two types of acceptance testing. One is UAT and another one is BAT. UAT, that is user acceptance testing, satisfies the contractual acceptance of criteria. BAT, system will eventually pass the user acceptance test. So this should be done in line with the regression testing. Regression testing in simple terms is an capture and replay kind of an test. Capture and replay kind of an test. So white box and black box. White box, it goes up with structural testing. You can test control flow or data flow. Now which one is difficult out of this? To detect the control flow or to detect the data flow? Of course, data flow we haven't checked up till now. We have checked, we have insisted on the control flow rather than the data flow. Black box testing is also called as functional testing. So it examines the program from outside. So internal details are been absent. So external interfaces has been evaluated, conducted by separate SPA group. So which one has to be done first? Black box testing has to be done first, and then if you find any problem, go into the structural testing, that is white box. It is not the reverse way, vice versa is not true, right? First do white box and then do black box. It is not recommended approach. So you require the test planning and design. So you should refer to the test plan. Various kind of test plans are being there. We should indicate the framework, scope, effort required. So very similar to project plan that we have written, and the test effectiveness matrix has to be written over here very carefully. That is defect revealing ability and so on if you are using a test suite. Many of the test suites are freelance, that is open source, and another category is the paid one, right? So it is based on how this costing has been determined is about how much support that has been given for black box testing. The importance has been given for black box testing, right? Because white box testing, of course, it is being an expected kind of an thing as by insertion of the checkpoints or breakpoints. So remember that the cost of the test suite is dependent on how many types of black box testing strategies can be applied with the test suite. Next is test automation. So why test automation has been recommended is that to increase the productivity, better coverage of regression testing. Now while uh, going to the next slide, I am taking a pause, let us say, and then clicking on. So the in between time is deleted. Only actual time is considered. So test cases can be automated, test tools are there, but what is the problem? The problem is that you should have the testing teams in groups. What does that mean? The software group will have software developers and integration test group. The system test group will have development, performance, scalability, automation, and sustaining the test group. The last group is hardware. So those many kind of again NFRs are been coming in picture. So hiring and retaining the test engineers is a very big job, right? So how the participants are being evaluated? First of all on the skills, and second thing on their efforts, right? So adequacy of testing, how we will determine that the test has been adequate or not. One is the mechanism of fault seeding, another one is program mutation. Another one is program mutation, that is finding out the variances, right? So what is fault seeding? Implant a certain number of known faults and test P with the test case T. If K% of X faults are revealed, T revealed K% of unknown faults. Right, so that is what is the underlining theme, isn't it? That one has to know. That is being done intentionally. Program mutation, okay, is the changing the current version to the next version. Mutation of P, again, that is part and parcel of white box testing and unit testing. A mutation P is obtained by making a small change to P. Some mutations are faulty, and then P is said to be adequate if every faulty mutation is not producing the uh, unexpected kind of a result. So, limitations. Testing can reveal the presence of faults but not their absence. Very true. These were being the statements from Ed Dishra, that is faults are detected by running P with small test set T, where the T is lesser than D, yeah, and then the size of function can be determined. There could be non-testable programs also. Why so? What is the cause of that? There is no test oracle presented, so expected output is missing. and it is too much difficult to determine the correct output because of the variances in the output. But these are not the dependable kind of reasons, okay, in the world of testing. So we begin with unit testing. One is static unit testing, another one is dynamic. Static unit testing, in that you may work around with the uh, code validated against the requirements by reviewing the code or inspecting the code. Dynamic, in that case, actually the program is been executed, and then you can see that static unit testing is not an alternative to dynamic unit testing. They are different in nature, as we are already aware. So inspection and walkthrough are the two key mechanisms that one can find out in static testing. You have to review the code, not to evaluate the author of the code. This is very important. So personal level criticisms are not acceptable in the world of testing. Yeah, just to pinpoint that this is very badly written, and how many times I should tell you that you should write in a correct way. So do not discourage the entities who have been presenting their program to you. So static unit testing, there are the steps. Readiness, the roles could be moderator, author, presenter, record keeper, reviewers and observers. Preparations, that is list of questions, potential change requests. Step 3 is examination of the code, and then the rework on the CRs, that is the change request. So here comes the value of the version control, alright, to fix the issue. Validation, independent validation has been performed and exit is the last step. Right, so just see it, these steps are being aligned, isn't it? Right from top to bottom. You have to have the criteria for readiness. By examining, you are leading to change request, and while exiting, you are generating the report. So the metrics could be lines of code reviewed per hour, 100 lines of code, 200 lines of code. That will again depend on the type of programming language you have been using. And then KLOC, thousands of lines of code that can be reviewed. So number of CRs generated per hour, that can be also metric, right? And one must do one thing here, is to set the deadline. Because if testing is not over, you cannot launch the release. This is what is the thing, alright? And you can compare it to the traditional methodologies as well as the Scrum, isn't it? Both of them, they need inspection, review and the automation tool support. So this is about the defect prevention. Let me jump out to dynamic unit testing. Dynamic unit testing, what is under test is the unit. So a test driver, who is the test driver? A test driver is a program. A test driver is a program that invokes the unit under test. That could be another program, right? It provides input data to unit under test and report the test result. The emulation, not the original version, emulation of the units called by UUT are called as stubs. Stubs are the dummy program. So if you have test drivers and stubs together, you call it as scaffolding. So scaffolding is a very powerful technique. First up, invoke the program under test, then have the dummy program, and then test the unit under test. So just try to see test driver, call and pass input parameters to the unit. Stubs are being generated. Yeah. Stub related reports are being printed and the output parameters are being conveyed to the test driver. Alright. Likewise, if you can compare the transport mechanism, right, in buses, bus driver, right, along with the bus conductor, right. Now, who are the stubs unit under test? People like you and me who travel, right? We are changing ourselves, so we are dummy programs, right? After reaching to the home, okay, we are no more a passenger, okay, inside the bus, right? But our actions, they will demonstrate about the result. So in common sense also, I tried. So mutation testing, we will emphasize. Just see to it, small change you are making to the code. Modified program is called as mutant. A mutant is said to be killed when the execution of the test case cause it to fail. So therefore, once a mutant is been killed, the mutant is been called as dead. If the mutant, that is changes that are been made to the original program, are still providing the same output, then it is acceptable, it is equivalent. A mutant is killable or stubborn if the test cases are insufficient to kill it. So, a test suite is said to be mutation adequate if the mutation score is 100%, means the effects of seeding the faults or making the changes is not that great, right? So, mutation score 100%, that is acceptable. Live and dead mutants, equivalent mutants, stubborn mutants, right? These are the terminologies you should remember. So, the program has been given. The changes for line, certain line has been changed, okay, changed 5 from 1 to 3, okay, and then you will observe the program will pass the test suite and are not killable. So, and if in the second test case, 1 to 1, the values of the rank is 2, 3, 1, 2, value of the rank is 1. So, mutant 2 will fail the test case and mutant 1 will fail the test case 1 and 2. So, 50% mutation score is there, okay, assuming mutant 1 and 3 are non-equivalent, right? So, this was about the mutation testing again. Debugging. There are techniques for debugging. Brute force, cause elimination, that is induction and deduction, and backtracking. Usually we go around with backtracking. Brute force, you may have listened about it in network security or may listen in network security. It is an attack, okay, that has been made and required to be addressed immediately, right? Dynamic unit testing, okay, you should draw a control flow graph very similar to the flowchart, but than showing the details with the flowchart, you are showing the nodes and the edges. There are 6 possible conditions that a CFG can have. One is the sequence, pure sequence. Next, if then. Next, if then else. Then while do, repeat until, and switch case. Data flow graph, DFG, can be drawn and then the inputs can be submitted. I have already mentioned it that data flow testing is a difficult kind of a job than the control flow testing. Other 2 options are domain testing and functional program testing. For domain testing, you have got equivalence partitioning and boundary value analysis as 2 techniques. So, tools, the names are there in front of you. code auditor, bound checker, and you can have JUnit also. Yeah, here if you are there with Java. And now the integration test. So straight away, the system integration test or SIT, its objective is to build a working version of the system. So let's go about the approaches. Yeah, these are the advantage, benefits, and common paradigms are procedure call interface, shared memory interface, message passing interface. So exteriorly you will be testing this. So interface errors, they are coming under black box testing, isn't it? You are not going inside the module or component because you are talking about the integration testing, right? So granularity is an important thing. First up, pair-wise testing. You should go with the pair-wise testing. That is two interconnected systems in an overall system are tested at a time. But before that, intra-system testing has to be performed. That is low-level integration testing has to be done first. Then inter-system testing, that has to be there. And then pair-wise. So what is the sequence? Intra-system, inter-system, and pair-wise. I have commented about the homogeneous and heterogeneous systems. So the difficulty is there lying with the heterogeneous system. So the difficulties are being there, okay, inadequate functionalities, misuse of interface, inadequate error processing, right? Validation of data constraints. By chance, by mistake, the validation of has been misspelled by me. That is OD. It has to be OF. Alright. So giving an input to the program, we have given the name. Likewise ABC. So that is an invalid name. Right? Even though you accept alphabets, but right combination has to be also detected. So you can have incremental, then top down, then bottom up, then sandwich, then big bang. So let us jump out to the top down approach. Just see to it. A, B, C, D, E, F, G are the 7 or how many? 7 modules, right? Now just watch at the figure 2. Top down integration of modules A and B, right? And by that time C and D are been isolated. Now top down integration of modules A, B, D, C is not considered here, right? So test the interface between A and D. The regression test is to look forward for the interface defects between A and B in the presence of module D, right? So again we have seen the drivers and stubs. Remember you, stubs are the dummy programs, right? Initiated by the test drivers. Parameters and input values are been given by test drivers. So figure 4, it demonstrates top-down integration of A, B, D and C. It should have been A, B, C, D, right? But C is consisting again E, F, G. So that's why when you are talking about a layer or a label, cover up the label A, B, not A, B, D, C. Okay. Figure 5. Top-down integration of modules A, B, C, D, E, F and G are being kept isolated, right? And except G, in the last example, you can see the rest of all are being combined. At the later stage, G would be also combined, and then we can say that if there are no defects for E dash, F dash and G dash, the original programs written are acceptable. So let us go to bottom up. You have got the test driver. So bottom up integration of the leaf node now. EFG, right? And then EFG, when they are being tested, then you can test BCD, right? And then you can comment about A. So work at a right level, isn't it? EFG has been picked up first. So horizontal, in some case this has been horizontal in the way, right? Bottom up testing, and vertical branch wise kind of an testing is there in top down, right? So comes up with the last few slides, right? One or two merits and demerits. Big bang, that is, first of all check the module individually and put them together. So this is not the best of the breed approach. Big bang kind of an model, we have seen the demerits of that. Sandwich approach, which is having mixed layer of top down, bottom up and big bang. And then you have to have 3 layers: the top layer, the middle layers and the lowest leaf. And then you should start with the lowest leaf to the middle and then to the top layer. So probably the last slide suggests about what are the dreams for software testing. That is the roadmap. So what are the achievements? If you see, comparison among the test criteria has well been set. Protocol testing has been existing. Model based testing is available. Anti-model based testing is also available. Test oracles you are already aware about. Online testing is also available. And testing process and reliability testing, about that some inputs are been available. So this is based around on why, where, when, what, how and how much. So what is the dream? Universal test theory, very difficult to achieve. Test based modeling. UML is general purpose modeling. Like that, variety of modeling languages are been existing. 100% automated testing. Right. This is a nightmare. I hope so today also. And maximizing the test engineering. So that's how probably we end up the session. I thank you all for patiently